Let's see if we are live. We're showing up live. Looks like it. All right. Live stream is up. Let me just send this here and we will get this cross-posted. Okay. Well, good afternoon, everybody. A little bit late in the day, but wanted to bring this video to you guys. Really excited to unbox this milling machine. Today I've got the 580 DC, which is a mill from XTCERA. This is a disc changing machine, so it's a little bit taller of a mill. We're going to be actually comparing this side by side against our 500 plus mill. So this mill that I have over here to the side, this is our standard dry mill that we have. The main difference being that this one does not have a disc changer, so you manually load the pucks in and out of the machine, and has a 1.8 kilowatt spindle. Very similar, almost identical specs to the 580 DC. But you guys have probably seen more of these 500 plus mills floating around in the market. They have come into the US market a couple years ago under the Zubler brand, but now XTCERA is selling direct, and we are one of the preeminent resellers for the XTCERA products. So today we're going to start out with unboxing the machine. But before we do that, I'm just going to make sure that our live stream's working properly on all channels, and then we'll get started. So thanks for joining us, and stay tuned. We'll get to unboxing this bad boy very soon. All right. And as always, if you guys have any questions whatsoever, please feel free to drop me those questions in the comments section, or you can PM me or Level Up CAD Cam for any questions that you have. So we're going to get started by actually opening up the crate. So my recommendation is probably start at the top, and then we'll work our way down. So okay. And this is the first time we've unboxed the mill straight from the shipping company. They just dropped it off for us yesterday. And in order to lift this mill, you really need a manual stacker of some sort. If you don't, we have partnerships with local moving companies. We can find somebody that can lift this for you. But basically, the machine itself is on wheels, so we don't necessarily need to lift it very far or lift it very high. We just need to basically lift the machine up enough to get it off of this pallet, so that way we can bring it down onto the ground. And once we have the wheels on there, just gives us a little bit more flexibility to get it to where we need it to go. Okay. Man, I might have removed all these prior to the stream to make this a little bit faster, but all right. So just because personally, I haven't unboxed this machine before, so we'll go ahead and remove some of these pieces one by one. So it looks like this is the side of the machine. Front end is facing left here, which is fine. This is a wider profile, so it's going to be easier for me to get the forks underneath of here when I do go to lift this machine up. So we've got some really nice packaging here. Got some cushioning, things like that we're going to remove. So I'm going to start by removing the pieces of the crate here. And I'm going to set these aside for now. Now, if you plan on putting these guys back together, one thing that I recommend doing is just taking a Sharpie, kind of marking some spots here so for alignment, get things lined back up. So let me just do that real quick. Eventually I'll be putting this guy back in the box. Right. And you can't really see what I'm doing right now. I'm just basically going around and marking my sides A, B, C, and D, essentially. All right. Of course, we already know what side's up, so let's go ahead and start removing these other panels here. So the whole point of this live stream today is just to show you guys. I know a lot of people get intimidated when they see these big mills, especially if you're coming from a desktop mill. You know, a lot of people think that these large mills are super complex, complicated to get set up. And the reality is they're just as easy. They're a little bit larger of a machine than what a lot of people might be used to, but there are strengths to that. So the machine is much more capable than most of the desktop mills that you're going to find out there. But the neat thing about this is even though the machine is so much more capable, the price of the mill is very comparable to those of desktops. So let me go ahead and get this out of the way, and we'll continue with our uncrating, unboxing. All right. I'm on the back side here now. I think what I'll do is remove the top first, and these two sides should probably be stuck together. Well, maybe remove the sides. This top is on there. Pretty good. So I might have to loosen the other side here. There we go. All right. And can't see me, I'm on the far right side right now. There we go. Whoops. Not too far there. Okay. Yeah, this one's a little bit more difficult to get off here. So let me get two hands. Good job. Okay, I was gonna originally take the top off and then move to the sides, but it's a little bit stuck on this one side, so I'm gonna go ahead and remove the sides, all the side clamps here, and then we'll see if we can't get the top off there. And then got a couple down on the bottom here to loosen up. It's probably also going to help me get the height I need to get it off the top here. Almost. Take this one off here. Could be the point where you ask for a second pair of hands, but we're trying to do it here without. Let's see. I'm gonna get this piece off here. Basically got two clamps up here holding this thing on. And sometimes this stuff shifts around a little bit in shipping, so let's see if I can do this without dropping something on my face here. There we go. Much better. Got that side off. So those panels, especially if it moved around a little bit during shipping, those can be a little bit of a challenge sometimes. So I'm going to go ahead and turn the tracking off, set this aside. Oops. There we go. Continue setting these pieces over here out of the way. Okay. Let's see. This final side right here. There we go. Okay. So this could definitely be a one-man job. Takes a little bit of effort, but just keep track of all your pieces. There we go. All right, and here we have the machine. So the next piece, which you can't really see, but I have a pallet stacker behind here. So once we get the machine off the pallet, I'll be able to show you guys the type of equipment that I have here. But right now, my goal is to get this machine up off the pallet. I'm just going to double check, make sure I have some clearance down here, which I do. I have plenty of clearance in between my wheelbase. And so let me go ahead and get my stacker in place here on the other side. Okay. All right, I'm just going to get my forks under there. Okay. Let me just put my brake in place here. And I'm just going to come over here to the other side just to verify that my forks came through on this side, which they're sticking out down below here, so that's good. You always want to make sure that we get the forks all the way through because there's sheet metal under there, and we don't want the lift point to be on the sheet metal. The frame on the edge, there's a nice thick piece of rolled steel on the edge of the frame of that bottom of the machine. So we want to make sure the forks go all the way under. So now that they're there, I'm going to go ahead and lift my mill. And at this point, I'm just lifting the mill up to get it up off the pallet so I can remove the pallet from underneath of it. So I still have the brakes on. All right, let's see if we have the height. I'm gonna go just a little bit higher here. All right. And we're gonna remove this pallet from under the machine, which I think I'm gonna move it back a little bit so I have room to maneuver it. So pop the brakes off here. It's a heavy mill, so you gotta be careful when you're moving this thing around. All right, there we go. All right, so more or less I've gotten the pallet out of the way. Let's see. You know what? I'm gonna put the pallet on the other side here. All right. Perfect. All right. And so we have our machine lifted up off the pallet. Next thing, I'm going to bring it down onto the ground. All right, here we go. There we go. All right, mill's on the ground. So let me take my brakes off here. Pull this guy out. All right. Good. Well, actually, you know what? I'll probably move this machine that way to get it out from under the forks because I don't have a whole lot of space behind us. Now, I'm just going to double check the wheels. Looks like right now some of these pads are down, so I'm going to roll these up. And basically, these are just pads that go on the bottom where the wheels are to actually seat the machine, so or keep it planted onto the ground. So when I lift these wheels up, I'm going to give myself clearance to be able to roll this thing around on the concrete. I'm just going around to all four sides because it looks like the pads were down on all sides, so it's good. Again, if you guys have any questions about this mill, feel free to ask. In the meantime, what I'll do is I'll go ahead and I'll post the specs up here so you guys can see it. All right. I think I've got almost all the wheels done here. One more on this side here. All right. Okay. There we go. Oh, I'm going the wrong way with it. I was. There we go. All right. Pads are all lifted off the ground. All right. Now I'm going to see if I can move this just slightly. Okay. And what I'm doing right now is just pushing this toward the camera and off of the forks. So it's the only thing you're not seeing from the back side here. This is almost I believe it's right at 900 pounds, this machine. So quite a heavy piece of equipment. But now that it's off the forks, it's on the wheels, we can technically roll this guy around. So let me go ahead and get it facing the right direction here. All right. And for those that were curious about what we had behind the machine to lift it, what I've been using to kind of handle it, let me just give you a little sneak peek here. You can see behind there is the pallet stacker that we're using. Might be a little bit hard to see with the exposure, but that's essentially what we have to work with. And let's correct the angle here. All right, there we go. All right, so right now this is the front of the mill, but let me take some of this protective packaging off of it. So we've got some nice foam, followed with shrink wrap. Shrink wrap goes all the way around. We've got some nice corner pieces for the foam here as well. So let me just get my box knife and we'll cut that off. Okay. I think we're going to just cut through some of this to expedite. We're not tearing off plastic wrap all day. Okay. There's the front. All right, so we've exposed the front of the machine here. Get you a better angle when we get the rest of this stuff off. So typically this machine will come in its own crate. The chiller, which is used to keep the coolant, or excuse me, keep the spindle operating at a nice cool temperature, that is actually included in a separate box. So we'll show you what that looks like in just a second. But we'll first get this machine unwrapped here. So inside we have our accessories box, as well as other key items that we're going to need for the install. And once I get the wrapping off here, I'll roll the machine around and give you guys kind of like a full view what's behind it. Now we're not going to be running the machine today. I'm hoping that the NC controller is active because they actually ship from the factory inactive. You never know when one's going to get lost or stolen, so they don't put a full license on it until it's actually at the customer's location. But we will attempt to get everything hooked up, and if we can, we'll try to see if we can get some of these discs loaded and show you guys how the robotic arm works, because that would be super cool to see. All right, there we go. So we've now removed pretty much all of the cushioning for the shipping that was included with the machine. Again, we have our cabinet down here. We can see the inner workings area with a lot of foam packed up there. This is the material warehouse is what we call this as far as the machine is concerned, where it houses and stores all of that. Let's see here. Looks like something might have come loose a little bit during shipping here. To double check this nut here. Okay. There we go. Perfect. All right. So I'm going to rotate the machine, give you guys a 360 view of what's actually inside of here. Real quick, let me just do one thing here on the stream. And I'm just sharing this this live stream out. All right. Share that out there. Cool. All right. So yeah, let me give you guys a 360. We're going to take some of the stuff out here that's inside of the machine. Let's see what we have. We have a couple. We have a variety of different power cables. This is going to be kind of your standard for 220, but depending on your plug variation, might be able to find different different styles depending on what you guys have installed. This is kind of like a standard, almost like a 110 power cable. And then this one, oh sorry, I think I showed you guys. Yeah, I showed you guys the one with 2 horizontal prongs. So I think this one's probably going to be more of your typical 220 volt power connection that you're going to have in most labs. So this machine does require 220 volts. The spindle is quite heavy duty compared to most desktop mills, so it needs that extra power. Here inside we have a couple of pieces of foam just to brace everything during the shipping process. So I'm going to take out these 2 pieces. One's between the boot, and the other one was between the cabinet. So got those removed. We'll set those aside. All right. And inside there is a security nut right here on the chuck. This chuck is air driven, so it uses air to retain and hold onto the fixtures once it loads that disc fixture inside. But before we can use the machine, before we can load a disc in there, that retention or security nut needs to be basically removed. So we'll get to that here in just a second. Down below here, let's remove some additional stuff. We got some additional packaging material. Let me angle this down so y'all can see. So a little bit extra packaging material down in here just to kind of keep everything together. Here we have the official accessory box for the machine. So inside the accessory box, you're typically going to find quite a few different things here. We have the automatic calibration jig. This is technically optional with milling machines, although all of our machines come included with the calibration touch probe accessory, as well as the calibration jig itself. You get a couple of extra screws in here, as well as some tools to work on the machine, items to work on the collet if you need to, as well as some tools and some other small screws as well. So that's our accessory box. We'll set that aside for now. And then let's see what we have down in here. We have our dust collector bin. Now this just sits underneath of the milling machine. And this is great because you know, most of us have dust collectors that have either removable bins, or maybe you have a dust collector that actually has a bag that holds your material. So this right here is basically going to catch, let's say 90% of your cutting waste, your cutting debris. It's going to catch it all right here. And it's a nice little plastic bin slash bucket that you can just pull out occasionally. And that's really going to save you a lot of maintenance on the dust collectors that traditionally will have a much smaller bin, maybe about a quarter, if not even smaller, maybe about an eighth of the size here. So let me go ahead and continue opening this stuff up. And just in case we get any questions, let me just check chat real quick. Looks like so far chat's doing okay. All right. And I think Facebook is still streaming. I lost my, here we go. Live now. Okay. Well, I'm assuming that my live stream for Facebook is still working. I don't see my screen anymore. So if you're on Facebook, I'm sorry. But we're going to continue here. If the live stream link on Facebook is not working, definitely check out our YouTube channel where you can catch it. As far as I can see, the YouTube channel is still going. Here is a second accessory box. Let's open that up and see what we have in there. All right, so inside of here, we should have our holders. Yeah. So here you can see all of our disc holders, adapters basically in this box. So we'll take it out and pop these in the machine. Okay. So these are labeled. I'll give you guys a close-up so you can see a little bit better what they look like. They're a little bit awkward to pull out. Set it on its side here to make it easier, maybe. Maybe not. We just take the whole thing out. Let's see. Might be easier to just push them out. Yeah. Okay. Ooh, they're in there, nice and good. Okay, so this is our disc holder. These are our disc holders. This gets mounted inside of here. This is the chucking indexing system. So it's going to sit in the milling chamber in the warehouse. So we'll just start putting these in. That's adapter 7. Actually, before I put these in, there's an additional step that I need to do to finish removing all of the foam, because as you may be able to see, there is still a little bit of foam inside of there. So typically we should just be able to pull this larger piece out. If we can't get it out of this opening out the front, then we can open up the side panel, which makes it a lot easier to get it out. That's what I'm actually going to do. Close this guy back up and open it up from the side here. So we have some tools in here, some hex wrenches. So if you need to get the panel of the machine off or work on the machine in general, this is what you'll have available. And so there's a panel here on the side. I'll go ahead and give you guys that 360 view of the machine. So on the right hand side, we really have service panels that kind of go all the way around the machine. There's service panels on the left side of the machine, service panels on the right, and then we have a couple service panels on the back as well. This panel up top is where we're going to go here in just a second, but did want to show you guys the back of the machine so you could know what to expect from back there. Make sure I'm not pushing up against anything. Good. Okay. All right, so yeah, we could probably even zoom in here, try to give you guys a good view. So down below here, service panel up top, service panel right here in the midsection of the machine. These are where the components to the main part of the mill are going to be housed. All the components up top are going to be basically for the robotic arm control if we need to service that at all. Again, there's a service panel on either side as well, just for accessibility. And then let me zoom in right here and show you what we have to work with on the back of the machine. So basically, we just have two exhaust ports here, and then we have our local area network. So this is where our Ethernet port for our internet is going to plug into. So this gets it onto the network, gets internet access to the machine, and if you need to, for transferring files, it's going to make it most convenient if you use the Ethernet port. The machine does have a wireless adapter. So today, I don't actually have a wired connection hanging in my lab. I'm going to use a wireless adapter that goes into the machine. And then this right here, there's two ports that look somewhat similar. This port right here is for the vacuum. So essentially this will automatically turn the suction on and off with the machine as needed. And then we have an additional port here for the chiller. This port is actually designed to take power, 220, from the machine to power the chiller, which typically the chiller can be mounted inside of the machine. However, you just got to be careful because if the machine is not in a well-ventilated area, typically it tends to get hot inside the cabinet. So what XTCERA actually recommends is to take the chiller and leave it external to the machine. And that ensures that the chiller doesn't overheat being in that small confined space. So, and before we get too far into this, let me actually bring the box up and show you what that looks like. So this is the box that the chiller comes in. And compared size-wise to the machine, it's pretty small here, as you can see. The chiller is inside of here. It's the same exact chiller as the one that I have on the floor over there. So I'll give you guys a much better look at what you're going to get in this box in a few minutes once we get the machine situated. But those are the ports that we have down here, and of course the main power port. So this is where our 220 volt is going to plug into. We've got a port here for the vacuum hose. I don't really think there's space underneath here for an actual vacuum, but you do need to route it inside of there to get to the actual machine. So that's down here in the bottom right hand corner, and again, additional service port, but generally speaking, you shouldn't need to open up this particular port. And then on On the far side of the machine here, we kind of glanced over it, but there's a small little vent here on the side that allows air to flow in. And then on this side, let me rotate this back around for you guys. Okay. And I'll show you guys what we have here on the left-hand side of the machine if you're looking at the machine itself. So, and I'll bring the specs back up so that way if anyone's curious, the specs will just be on the screen here. So this right here on the left-hand side, this is going to be our air regulator. So this is where we're going to plug in our oil-free, moisture-free compressed air line. And the machine itself requires 0.7 megapascals of air. You also have a digital readout meter down here. So it's going to show what the machine's actually receiving. So we'll finish rotating it back around here. Let's see. Okay. Thanks, Aubrey, for letting me know about the live stream. Still working on Facebook. So I'm going to go ahead and continue rotating the machine here. We're going to get it facing forward again. Okay. Great. All right, so I'm going to plug this in. Or, well, get it in position here first. Give you guys a little bit better of a view. Maybe too good of a view. Let's push it back a little bit. Okay. Now, packaging material, I guess I should have left it a little bit tilted here. Let me go ahead and rotate this just a little bit. We'll zoom out. All right, so this is where I'm going to use my, my wrench here. Go ahead and remove the side panel, and that should give us access to our milling warehouse. All right. I'm just going to loosen these up a little bit, and then I should be able to just remove these by hand. Okay. I'm going to grab myself a little bowl to kind of help keep track of these as I remove them. Oh, dropped my first one and my second one. Okay, let me grab that one before I lose it. Okay, recovered. They're pretty short, so it can catch you off guard. They just pop out there. There we go. Okay, I'm down to the last one. I recommend keeping an elbow up against this panel because there's nothing really retaining this particular panel. It'll just typically pop off if you're not watching it. I'm going to set this aside. All right, and now I have enough space to kind of get in here and get this foam out. So let's see. Best way is to get this guy out. Kind of turn it sideways like this, and then you can kind of bend it, and then foam just kind of comes right out. So that's our first piece of security. This kind of sits in there, holds the robotic arm in place during the shipping process. And then there's two additional pieces of foam typically in the back here. There's one that's going to be under the robotic arm, keeps it from crashing down in the Z-axis during shipment. You can kind of rotate this one sideways and then just kind of pull it out. So there's that. And then for the last piece, it's typically up against the far side, and I know it's hard to see. Let me see if I can show it here. Maybe even zoom in with this guy. So if we look close enough, you can see that there's this piece of protective foam for shipping in the back here. Generally speaking, this should be able to pull straight out. If you're not able to pull it straight out, then we might have to move the robotic arm because it kind of holds it in there during the shipping process. So we'll come back to that particular piece since I can't get it out right this second. But we don't want to forget about that one. That's very important because obviously that's going to be in the way if that robotic arm starts to move around. So we will return to that later. In the meantime, I'm going to go ahead and start removing these adapters and placing them inside my milling warehouse. So we're going to start with adapter number 1 and just work our way down the line. Man, they really pack these tightly. That's a good thing, I guess. There we go. Got adapter 4. So we have 12 disc changers here, which is really going to enable you guys to run lights out operations. And the nice thing about this mill compared to most desktop mills is its upper end is a lot more capable, which means that with these 12 discs, you can really compete with the smaller mills that you'll be able to fill this one up, because I hear a lot of people tell me like, okay, well, are we ever actually going to fill up those adapters, all 12? And I'd say it really depends on what you're working on, you know, because it's not necessarily 12 zirconia discs, it's not necessarily 12 PMMA discs. You might have a mixture of both, and that's one of the beauties of having a machine with a disc changer. You know, whether you're high production or you're just, you know, a lower volume, but you don't want to have to constantly be loading the machine throughout the day. It's nice to be able to just have those materials in the machine ready to go whenever you need them. So you can also, by the way, purchase additional adapters if you need them. But generally speaking, I found that these 12 will be all you'll need. So, okay, number 11. And then finally, adapter number 12. All right, so we have all of our adapters loaded in the machine nicely. All right, I'm going to run some power over here for it. You know what? I have a power cable already here for my 500 plus mil. So I'm just going to steal that instead of opening up a new cable. And we will plug this into the back here. So some other requirements for this machine, as you can see in the specs, there's an air requirement. I think we have 0.6 MPa, but the reality of where you want to be is closer to 0.7. And I'm just looking inside of here to see if I can find that little nut that went loose during shipping. Not seeing it, so I'll have to replace that, but no big deal. It might have fallen down inside of the machine. Okay. All right. So that is the machine unboxed. Now we definitely want to remove that security nut that's down here in the milling chamber. So let me change the angle a little bit so you guys can see what I'm doing. See what I'm talking about here. All right, so here's our milling chamber. I know it's going to be a little bit difficult for you guys to see with the low light, but basically right here is my security nut. So I'm going to use my spanner wrench to loosen that up. Okay. All right, so it shouldn't be very difficult. That bolt just comes straight up, and then there's a small little washer on it as well. So here you can see what that looks like. This is the security nut, and it just literally screws straight down into the chuck, and then you just remove it. Keep this. This needs to go in your accessory box. So don't lose that or any of the foam. You want to keep all of that just in case the machine needs to be shipped anywhere. It's nice to have all those incidentals. So, all right. Now the only other piece that I need to be concerned about before the machine becomes operational is going to be that foam piece that's on the inside there. So up in the robotic arm chamber. So I'm not too worried about that right this second, but let's see. Once we get the machine powered on, we'll get some power over to that robotic arm, and then we should be able to move things around inside the mill. So I'm going to go ahead and we're going to take a quick pause here. The stream will continue, but I've got to turn on the compressor and hook up my compressed air line. So I'm going to hook the compressed air line up to the bottom here on the side where that regulator was that I was showing you guys before. And that's going to get us our compressed air. And that's, again, going to operate a few different things. Spindle being one of those, the air-driven chuck for the fixture as well. All right, and bear with me. I'm going to go ahead and open up my garage door to get my compressor outside and turned on here. So we'll get that going, and then we'll continue streaming in just a sec. All right. Compressor's in place, and we got that turned on. Okay, good. Check to see if our air's coming through. All right. Now I'm going to go ahead and turn the power to the machine on in just a second. Before I move on to that, I do want to talk about the chiller here with you guys. And we're actually going to borrow my chiller from my 500 Plus because this machine actually uses an identical chiller. to operate, and then I'll show you guys how we hook that up. So let me get this guy front and center for us so we can get a better look at it. All right, so this right here is our industrial chiller. So we have some recommended coolant that you can purchase local to the US domestic market to fill it up. Basically, there's a full meter. You just want to keep it topped off. The coolant in this machine is really the #1 preventative maintenance that you have to worry about on a yearly basis. Once a year, you know, if you go a little bit longer, I don't think it's going to cause a big deal, but typically at the year cycle is when you want to drain out all the coolant from the system. And the easy way to do that, you've got an in and an out. So you remove the out from the back of the machine. You basically put the hose in a bucket, let it pump all the fluid and coolant out and into the bucket. That essentially flushes the system. Then you can then put new coolant in there and let everything run back up to the machine. So where does this hook up to inside of the machine? It's designed to be able to be placed inside of the cabinet down below here. Here's extra hose for the suction, and that's basically going to go. The hose for the suction is going to go right. Well, can't really see it. It's right here on the back side. You can kind of see there where my hand is. There's a small little section there that hose goes on, and it goes out the back there to go to your dust evacuation unit. So if you've got this machine comes with a Renfort PowerCam EC, which is basically a silent but a very powerful vacuum. You do need the more powerful of those two units. I know there's like a silent. I don't think it's the PowerCam, but it's like their silent compressor. That typically doesn't have enough CFM. You want to have the larger of those two suction units, so that way it's constantly keeping the milling chamber at a negative pressure situation there. So inside the machine, it's very difficult for you guys to see on camera, but there are two little silicone tubes here that are sticking up. Basically, those are run to the back of the machine. I'm going to just put this in line with my coolant. So generally speaking, these hoses would just go straight into the back of your chiller. What I have here is I just have adapters on my chiller cable, so that way I can hook it up in line, and I've got like a little shut-off valves. These are not necessary. I just have it here. One of my customers also had this kind of hooked up directly to the back of the chiller. Perfectly fine. In our unboxing videos, particularly our instructions, we actually advise that you can put this inside of the machine's chamber. Again, that's completely fine, but you do need to keep in mind, you know, if it heats up, and in particular, if you see the temperature on your chiller go above 25 degrees, I think it's typically something like once it goes above 30, 33 degrees Celsius, then the expansion of that fluid can actually impact the milled result, because it's actually flowing that coolant through the spindle to kind of keep the temperatures consistent, keep things working properly for you. So if this heats up too much, you might start getting an alarm from it. And if that's the case, you want to take this out of the machine. Alternatively, I'll tell you what we did for my customer up in South Dakota here recently. We just simply removed this door. So this door is on like a little bit of a spring hinge. It's kind of an awkward angle, but you can just basically pop this down to remove this door, right? So there's just one small little piece that holds it on there. So keep mine connected there. And instead of mounting mine inside of the machine, I'm gonna just put mine alongside of it, and I'm gonna run those hoses out the back and just hook it up to this chiller in line here. and then we'll get the power connection to this chiller going as well. Now, on the back of the machine, I was showing you guys kind of like a special connector. This is that special connector that basically goes to the, this goes to the back of the machine, and then the power end goes to the chiller, which powers the chiller. So chiller does require 220, so it either needs to feed directly off the machine, or if you're missing that connection for whatever reason, you can actually use one of the same adapter cables that the machine needs. You can use one of those as well to connect it. All right, so I'm going to hook my power up to the chiller. And basically, this socket is pretty easy. It only goes in one way. All right, and let's see, I don't think my power cord is going to reach all the way up there, so I'm going to bring this guy close to the back. All right, and I've got my power cord about to plug in, which is good. And then I'm going to take that hose, and we're going to, again, just hook it in line here. Does it matter what's in, what's out? Not really. They're not labeled, and it's going to circulate through the machine regardless. It's going through there, so I'm not too worried about it. All right, so I've got my hoses in place now. I've opened up those valves. I'm going to turn on the machine, and the first thing I'm going to do, now you can't see me back here, but first thing I'm going to do is just check these junctions for any leaks. Make sure that my coolant is flowing through the system once the machine turns on. But we've pretty much got everything where it needs to go. So I think my compressor is going continuously. Let me just check and make sure that that it's not sitting out there wide open, and then we'll turn the machine on. Okay, we're getting up there. Good. We're getting up to where we need to be. All right, so we're going to go ahead and crank this guy on. All right, so we have a single power button over here with our emergency stop button. I'm just going to hit my power button. Machine's going to boot up. So the machine features a built-in controller, so you don't have to have a separate computer to run this milling machine. It actually has a computer built into it, albeit not a very powerful one, but it is a computer. Doesn't require a whole lot of power to run CNC machines, so that's quite all right. So what we're going to go ahead and do is I'm grabbing from my kit this wireless adapter. This is the small little, it looks like a tiny little thumb drive that you'll find included with your milling machine. On the right hand side, there's a couple USB ports over here. I'm just going to plug it into one of those free USB ports. Now the purpose of the USB ports are if you need to upload or load files manually, you can pop a thumb drive in there and load it. Some people don't like the touch screen, so they maybe have a wireless keyboard / mouse combo. You can also hook that in. It's just a standard Windows computer. So, all right. Looks like the wireless adapter is set up, so that's good. Let's see if we can get it connected here. Well, let's see if it shows up. Wireless network and sharing center. Adapter settings. Okay, let's try removing it and plugging it in again. Okay. Had an auto pop up, so I'm just launching the application for the software. For the it's basically just drivers. It's the only exe that you can run when you click on the Mercury device. And now it's just installing the drivers. Install it anyway. Generally speaking, this should work out of the gate, but if it doesn't, obviously, see, we have options here. So I think it's finishing up now, and once that gets done, we should be able to see if we can get it connected and online. Now, while that's doing its thing, I'm just going to minimize this for a second, if I can. All right, and then I'll launch the controller here. Just want to see whether or not the controller is active. Oh, the license will expire in 1 day. I'm lucky. All right, I got 1 day left. First message, we got a red light bar going across. This is our status indication bar. When the machine is milling, it's going to be green. When the machine is done, it's going to be amber or orange to indicate for you. Again, here's our emergency stop button. It says it's pressed, so I'm just going to rotate this to clear that out, and then I can reset that. Now, the first thing I want to do, again, before I run anything or do anything, is I want to get that robotic arm out from the wall, so I can get that protective foam out as well. So let me go ahead and do that. I've got to enter a dealer menu here in order to do that. So I'm going to cover up the camera here. Okay. And what we're going to do, I'm in 0.1 increments, so I'm just going to jog this. I believe it's X. Yeah. Let's go to 1 million. All right. X positive is the direction I need to move. So I can change my increment here. I always want to start with a very small increment if you're not sure which direction an axis needs to go. But as you can see, you may have seen that robotic arm kind of moving out of the way. So now I can effectively get back to that piece of foam that was wedged up against the side here and just remove that. So this is the other piece of shipping foam that goes with the mill. And so just set this aside for now. All right, and as far as unboxing everything to the point to where we need it to be, that works well. Okay, I noticed that when I turn this on, the chiller didn't turn on automatically, and that's just because there's a power switch on the front of the chiller. So I'm going to flip that power switch. Chiller's now getting power. Now I'm going to go and double check my coolant lines, just make sure I'm not having any coolant leaking out. All right, and it just completed its first loop here. So the coolant is flowing through the machine and everything looks to be good there. So, all right. Now, typically at this point, the machine is almost completely operational. The only other thing that I typically tend to do before I run these machines is, well, twofold. After it's been shipped, we always want to make sure that we calibrate the machine. So we're going to try to walk through a calibration, but before we do the calibration, another thing I like to do is I like to run through a cycle test of all the various disc adapters in the machine, just to make sure that we're not running into any robotic arm positional errors, also to make sure that the chucking mechanism and everything's working properly. So one other thing I'm going to check before I get operational is I'm going to go look over here on the left side of my regulator, and I can see that my air is a little bit on the low side. So I'm going to raise up my pressure. See if I can get that a little bit higher here. Okay, I may have to adjust the upper end on my compressor. So maybe what we'll do is we'll check to make sure the robotic arm is working. I'm not sure that this is going to be enough pressure to operate the chuck. So let me see if I can increase my pressure. Okay, looks like I'm capping out at 0.58. So I think this is more an issue with my compressor. I'm going to have to adjust the top end of it and make sure that it's maintaining 0.6. We can give it a go and see how it goes. I think that if we drop below 0.6, we're probably going to have an issue, but let's see what we can work with here. All right, we're going to go into our automatic dish changer. That looks good there. All right, so what I'm going to do is load a test program here. And the job of this test program is essentially just to go through and pick up the various different discs and place them into the chuck. And then place them back in the milling warehouse. So, okay, it's E drive that I just plugged in. I just put a thumb drive in there. Let's see. Scroll down here. All right. All right, and it looks like it's not loading it. So let me check my settings here. Let's see here. All right, so let's see if that works. There we go. All right, and we'll give this a go. All right, just giving it a second here. Okay, so we're getting a different message here. It's failing on the RFID. All right, let me just check this setting here. Done. So I think that because I don't have enough air to run the chuck, it's going to give me this error message. So everything's going to turn red and let me know I need to adjust my compressor. So we'll probably do that for the next stream, because I might need a slightly more powerful compressor. Didn't realize that my top end was set so low. But what we're going to go ahead and continue doing is I'm actually going to go through the calibration process, because that is something that we can do, and this is part of the normal process. So we'll go through and actually calibrate one of these. And let me get that robotic arm back up and out of the way. All right. Now, for the calibration, we're just going to simply mount that calibration jig inside of one of these holders and then manually mount it inside of the machine. So hopefully there should be enough air to operate the chuck to allow us to manually place it in there without throwing an error message. We'll see. We'll give it a test real quick just to find out. Okay, so there's definitely enough air to operate the chuck, just not enough to do it without alarming the system. So I'm gonna go ahead and mount our material, or excuse me, our calibration jig in here. Now, included with your machine, you're gonna have this T-handle spanner wrench. And so it's what we can use to easily put things in, or mount discs and materials inside of our holders. We're going to grab our calibration jig. So this right here is our calibration jig. It only fits into the disc holder in one way. So as you can see here, it has anti-rotational grooves for indexing. And we'll get those mounted in here. All right, so here we have our calibration jig mounted. Pop this plate on there, and now we're going to secure that in place. Now my recommendation is if you're going to handle this jig, before and after, it's good to handle it with gloves. If you don't have gloves, then just make sure you wipe it down after the fact, because you do have oils in your hand, and those oils, when they sit so long on a surface, can tend to corrode the metal. So you just want to make sure you keep this nice and clean. Now, before I load that in the machine, I'm going to take the other calibration piece here, which is the actual touch probe itself. Basically, this will screw in to the inside of the machine, and then this one this piece right here will actually get mounted into the collet. So, and then this is the touch probe that it's going to use to validate the calibration. So I'm going to go ahead and mount this inside of the machine, inside the spindle. Now, it's pretty easy to mount tools inside of this machine. Very similar if you've operated other mills of this size, where you load the tool directly into the collet. Basically, there's a option here that says collet. I'm going to push that button. When it does, the collet's going to open up, and I should get a blast of air out. Oh, it has a security shank down in there as well. So if you heard that drop out inside the machine, no big deal. It's just there for shipping. So I've got my collet mounted in there, or I've got my tool mounted into the collet, and now I just press the collet button to clamp it shut on there. And so now the tool, the calibration jig or the touch probe, is properly secured into the spindle. Now I'm going to remove the protection cover here for this port. It's a 3-pin, but it only goes in one way, so you can't get this one wrong. So I'm going to line up a single one down below. There we go. That went in nicely. Now I'm just screwing it in to hold it to the port. That way it stays in place. I'm trying to anyway. Make sure it's not in there nice and tight. There we go. Got it nice and secure. Okay. Next up, I've got my calibration jig mounted inside of one of my adapters. Now I'm just going to go to my adapter control, open up my chuck. All right, make sure that's in there, nice and indexed. Chuck is now holding it securely in place. So at this point, everything is ready for the calibration process to start. I guess I could probably leave this open here. We're going to go and click on calibrate. It's saying learning instructions of this function. Be sure to calibrate the disc holder. Yes, we want to calibrate it. Okay, so right now it's touching off that touch probe there. And I'll see if I can get you guys a closer up shot of what's actually happening inside of the machine. Let's bring it down here. There we go. So as you can see, everything touching off on there. And we typically, and this is one of the nice things about these particular machines. These machines are really built to hold their calibration. So in terms of accuracy, repeatability, that's really what these machines are built for. In fact, this automatic calibration is really just a convenience measure because we don't really have to calibrate this machine often compared to most desktop milling machines. These machines probably need to be calibrated once every 1 to 3 years, and that really depends on how hard you're running the machine, what materials you're running in the machine routinely. But basically, these machines will hold their calibration, and they're overbuilt for that purpose. You know, one of the reasons we chose these particular machines is because they're extremely rigid, and the accuracy of the types of parts that they're able to reproduce are just, you know, hands down so much better than traditional mills that we've seen in the market. So the nice thing about this is that, you know, you get a heavy duty mill at a price point of a desktop mill, and so it's extremely great value. I think these machines are so undervalued in terms of what they're actually capable of, you know, that's one of the main reasons that we are choosing to promote it. So we'll let this auto calibration process play out. After the auto calibration process, we'll give it a go and see if we can go through our standard process. I'm going to see if I can go outside and raise the pressure on my regulator while that's going, and we'll be right back. All right, so raise the air pressure on my compressor out there. So I think we'll probably be good to go here. So we'll let this finish up here. All right, and while this calibration process finishes out, I'm going to take a quick little break and we'll resume back here probably in about 3 minutes after this calibration is done. All right, so it looks like the calibration process was done. We got a success message on the calibration screen over here, just letting us know that everything was good. There's our auto calibration success message. So good, our machine is calibrated and we're ready to run some parts, except for the robotic arm we want to check. So let's see here. Remove this. All right, and we're going to go ahead and remove that that piece from the chuck. So I'm just going to show you how that's done here. So as you can see, I can just reach in there. I want to grab a hold of the probe so it doesn't go flying on me, but I'll unscrew it here from the port first. Get this side loose. I always like to mount the probe into the spindle first, because that's, if you think about it, that's the business end, that's the fragile part. So getting it mounted first, then screwing this part in, or screwing this part in and then mounting it, I think that it's safer to have it inside the spindle when we can. So now I'm going to go over to release my collet. Pops out. And we just push the button to close the collet again. I'm just going to go and put my touch probe and calibration stuff back in my box. So that way we don't lose anything. I keep everything together always. And now I'm just going to go ahead and remove that adapter. Remove it from the adapter anyway, that jig. Okay, loosen it up. Here we have our jig. I'm just going to give this a wipe down, and then we're going to put it back inside of its container for safekeeping. And it's most important that if you touch the sides, I don't think it's as big of a deal, but if you touch any of the touch-off points, I think those are the areas that you really just want to avoid getting anywhere close to. Okay? All right, so we've done that. Now back to our machine here. So I think that earlier I was receiving a message about my compressed air, but now I'm probably going to get a message about the RFIDs on these fixtures. So let me just check these and make sure it's set up properly. We talked about that little pin that goes inside of the spindle while it's shipping. So this is basically, it's just pre-mounted inside of the collet. It's just a blank. So it's not super important, but it is something that I would hold on to in case you ever need to ship it. That way you don't have to ship it with an actual tool in there. You just have everything together. And I would just keep this with the, probably with the security nut for the chuck. So that way, keep it all in one spot, okay? So here's my adapter number one. Let's see about putting that back inside the machine here. All right, and I'm just gonna do a once over of all of my settings here to make sure that I have everything set up properly. Let's see here. All right, let me just go into my settings here. All right. Okay. Zero. Okay. Fleet 24. Okay. Fleet 24. One. Okay, let me just check the other settings here. Okay. Okay, let's try that out and see. Better luck now. Let's see if we can pick up disc number 1. Okay. Okay. All right, so what I've basically told it to do is just basically to pick up disc number 1 and take it down, and basically place it inside that milling chamber. So everything's looking good there. Now this is just kind of like a manual check. What I'm going to go ahead and do is run my program that will check all of those. So we'll just check all adapters. Let's reset it. We're going to start this program. And so essentially what it's doing right now, it's running the preset program that's actually utilized to blow off all of the material off of the disc adapter and off of the disc itself. So this actually is this is like a little preset program that just runs at the end of every milling job. And what we're doing here is just picking up that disc, and it's taking it up, putting it in the milling warehouse, and then it's going to go and pick up number 2 and kind of continue down that line. And so this is just a cycle test program. This is basically just designed to make sure that the robotic arm is working properly. And so it's going to continuously cycle through, picking up all of these disc adapters, replacing them back into the milling warehouse. And I'll see if I can give you guys a better kind of close-up view of what's going on inside the machine. In fact, what I'll do is I'll take the side panel off here so you guys can kind of get an up-close view and see it a little bit better. But we'll zoom it out while that's changing out discs and stuff so you can kind of see the entire process. Again, if you guys have any questions, feel free to leave those in the chat down below. If you have any questions about the machine itself, you can also send me a PM message, send it to me or send it to Level Up. If you're interested in seeing this mill in person, we will have it at Lab Day Chicago, where we'll be exhibiting. We're going to be exhibiting in the West Hall, but this machine will be on display at the CIM System Milling Open House, which is typically in meeting rooms over close to the West Exhibit Hall. We held our first open house. I say we, Sim System held their first milling open house last year at LMT Chicago, and it was an extreme success. And I really suggest everybody to get out to the milling open house because there's not many places where you can see almost all the milling machines, at least all the predominant ones that are in our market, on display in the same location and talk to representatives from those companies. So I'll be representing XTCERA on Thursday, and then on Friday, I can't remember, Friday or Saturday, I'm speaking for them, but just check our schedule and our agenda. And I know the milling open house will be actually open to the public on Friday and I believe on Saturday. Excuse me, Thursday and on Friday. It'll just be open. I know that SimSystem's holding their seminars typically in that same room, so definitely come out, see what's going on, see what's new, and learn about what's out in the market. Don't get stuck on one brand. Millbox is a multi-machine capable cam, which means that you don't have to worry about the machines that you're running. You just want to get them all working with a singular cam software to simplify your workflow. So let's see if I can get a better angle here for you guys to see what's going on in there. And there's the robotic arm, just getting things mounted in the chuck. And we've got a little door that shuts to keep the dust out. There we go. You guys have any questions? Again, let me know in the comments. I'd love to hear from you. If you have any comments at all, those are welcome too. And I'll try to see if I can get you guys a front view. A little bit lower here. All right, so I'm just running it again for those of you that are just now joining us. I'm running it through a manual cycle test. And the job of this program is essentially just to go and grab discs 1 through 12, place them in the chuck, and then go back and retrieve those and put them back into the milling warehouse. So it's just kind of going down the line one by one. We're now up to adapter number 11. And generally speaking, I'm going to let it run through this cycle twice. Now, we're probably not going to do that for the live stream, but I did want to show that to you guys as these are some of the main processes that we would run in order to get this machine going. So the last shots that I'll give you guys here is kind of a close-up in the milling chamber to kind of see that chucking mechanism in action, and how the robotic arm comes down from the top. All right. Now for the 12th adapter, we'll go ahead and move this down. And let's see if I can get you guys a little bit lower of an angle here. Actually, let me just pop this down here. It's going to be a weird angle for a second, guys. Okay, here we go. Let's get you guys a little bit higher. Why is it higher on this side? That's one. There we go. Now you should have a much better view. Once I adjust this. There we go. There, and from this angle, we can see that robotic arm come in, and then the chucking mechanism, how that all goes down and in place here. So I'll leave the specs up here as well. Again, if you guys have any questions of anything, let us know. Happy to answer anything. And here are the specs on the 580 DC. So the machine itself has a 1.8 kilowatt spindle, very powerful machine for dry milling, zirconia, PMMA, PEEK, any kind of plastics. You know, if you're doing removable partials or just dentures themselves, this is a really great machine for that. It has a very high repeatable 3-micron tolerance on the accuracy. Spindle can ramp up to 60,000 RPM, although we'll typically never run it that high. The feed rate's at 6,000 millimeters per minute. Again, that's just the capability of the machine to move quickly during the machining process. Most of our processes run it close around 3,000, 4,000 millimeters per minute. And on average, it's going to be about 30 to 40% faster than your average desktop mill. So if you guys are used to the smaller mills that kind of fit on your desk, this machine is meant to outperform those. And in terms of preventative maintenance, well, that's one of the biggest benefits of this type of a machine, is that it's so rigid and overbuilt for the purpose of milling zirconia and PMMA that it doesn't really need calibration very often. So we might perform a calibration once every 3 years, once every 2 years. Again, it just depends on how heavily you're using the machine, what materials you're running in it. But this is the 580 DC from XTCERA. So I hope this video was instructional for you guys. I hope it was educational, so you can see that these larger mills are really not, they're really not intimidating at all. You know, there's the fact that they are large machines. You know, for a lot of people, that in and of itself is very intimidating. But in terms of operating it, we've actually had 2 different labs now that have done their own self-installs on these mills. So they've installed them pretty much remotely themselves. And those customers are currently running production. Everything is running extremely well. Sorry, let me I'm trying to fix my camera here. My jig came loose for some reason. Apologies for that. Interesting. Okay, well, we'll fix that after stream. But again, just wanted to show this machine off to you guys. And if you have any questions, let us know. Again, this is the 500 plus over here. This is essentially the same thing as the 580 DC, although it's a single disc at a time. So you essentially load this machine by hand, but the specs are very similar. 1.8 kilowatt spindle, 1.8 kilowatt spindle. This machine over here, the 580 DC, again, almost a clone. The only difference is the chucking mechanism, and then of course the robotic arm and the milling warehouse. So this machine will afford you lights out operation. If you're looking to dip your toes into the field and you're really looking for a machine that's just extremely reliable, maybe you're wanting to replace 2 mills, this machine is really good at that purpose. It's a tank, it's built to last, and it's built to perform. So again, really appreciate you guys tuning in today. I hope that the live stream was good for you guys. And again, if you have any questions, feel free to reach out. My name is Mike. I'm with Level Up CAD CAM, and we'd love to support you guys as you expand your milling center. Thank you. Take care. Bye-bye.